All right, let's dive into one of the most incredible and honestly underappreciated organs in our entire body, the kidneys. We're going to take a look at how this ultimate filtration system performs a constant, life-sustaining miracle, all without you ever having to give it a second thought. So let's just start with a number that is, well, it's just staggering. Every single day, your kidneys filter about 180 liters of blood. To give you some perspective, that's basically like filtering an entire bathtub full of liquid every 24 hours. It's a colossal task, and it's happening inside you right now.
So this massive filtration rate, it brings up a really critical question, right? How does your body manage to flush out all the waste products without also getting rid of all the good stuff, like water, glucose, and essential salts? Let's unpack the absolute genius behind this process.
It all comes down to one word: balance. Your kidneys are the master regulators of your entire internal environment. Their main job is making sure everything in your blood is just right, perfectly in equilibrium.
And the key concept here is something called osmolarity. Now, it sounds a little technical, but all it really means is how concentrated your blood is. If you've got too many particles, like salt, your blood is too concentrated. Too few, and it's too dilute. The kidneys are working around the clock to keep this balanced in a very, very narrow range.
So what happens when that balance gets thrown off? Well, let's say you're dehydrated. Your blood becomes too concentrated. And to try and even things out, your body literally starts pulling water out of your cells, causing them to shrink. Now, this is a dangerous situation, but luckily your body has an incredibly elegant way to respond.
This is where a beautiful feedback loop just kicks into gear. Your brain detects this imbalance and releases a hormone called ADH, that's antidiuretic hormone. ADH is like a messenger that runs down to the kidneys and basically yells, "Hey, hold on to the water, don't let any more leave." And the kidneys listen. They reabsorb more water back into the blood, diluting it and restoring that perfect balance. Okay, so how do the kidneys even begin this massive filtration job? The answer is surprisingly simple. It's all about pressure. It's really just a physical battle of forces that's happening inside millions of tiny little filters called glomeruli. Think of it like a constant tug of war. You have one big force, that's your blood pressure, pushing fluid out with a pressure of 55. Then you have two smaller forces pulling fluid back in, and they add up to a pressure of 45. Well, you can do the math. The pushing out force always wins, and that's what drives the whole filtration process.
And the result of that winning pressure battle is a consistent flow of filtered fluid. We call it the glomerular filtration rate, or GFR. It's about 125 milliliters every single minute. You run the numbers on that, and that's how we get to that unbelievable 180 liters per day.
Okay, so we've filtered the fluid, but remember our first question? How do we keep all the good stuff? Well, this is where the real magic happens. The fluid, which we now call filtrate, starts this long journey through the kidney's incredible recycling plant.
So let's follow the path. It starts in the proximal convoluted tubule, the PCT, then it travels down and up the loop of Henle, moves through the distal convoluted tubule, or DCT, and finally it enters the collecting duct. Every single stop on this journey has a very specific and very important job.
So right out of the gate, at the very first stop, the body reclaims a huge amount of what was just filtered out. About 2/3 of the water and all those valuable solutes are pulled right back into the blood. This is the first and biggest step in making sure we don't lose everything.
And the selectivity of this process is just incredible. Take something valuable like glucose. The body makes sure it's fully reabsorbed. It doesn't want to waste any of that energy. But then you have a waste product like creatinine. That gets filtered and then just left alone to be escorted out of the body. The kidney knows exactly what to keep and what to toss.
Now, the loop of Henle. This part is so clever. It uses what's called a counter-current system. As the filtrate goes down one side, water is pulled out. As it comes back up the other side, salts are actively pumped out, but water is trapped inside. This whole setup creates a super salty environment deep in the kidney, which is the secret to concentrating urine and saving water when you really need to.
So after all this incredible filtering, reabsorbing, and fine-tuning, we're finally left with urine. So what's the last step? How does the body actually get rid of it? Well, this involves a really fascinating reflex. It all begins with a stretch. As your bladder fills up, it sends a signal to your spinal cord, and that triggers an automatic reflex. This tells the bladder muscle to contract, and an internal muscular door, the sphincter, to relax. It's your body's way of saying, okay, it's time to go. But here's the key, all right? That's not the whole story. We also have a second, external sphincter that's under conscious control from our brain.
This is what gives us the final say, allowing us to override that automatic reflex until we decide the time is right.
So let's just bring it all back home. From that massive 180 liters of fluid filtered every day, this whole intricate system of tubules recycles and reclaims over 99% of it, and we're left with only about 1.5 liters of waste-filled urine. I mean, it is an absolute masterclass in biological efficiency. This incredible system of filtration, selective reabsorption, and feedback control, it's really a marvel of natural engineering. And it kind of leaves you with a final thought, doesn't it? What other complex systems out there, in our world, from city water supplies to economic models, what could they learn from the brilliant design of the kidney? Thanks for joining me.